Welcome back. Thanks for joining us today. What we'll be showing you today is a fitting that we use internally. We manufacture this for ourselves. And what it is, it's a common rail diesel fitting for a testing machine. And what it does is it allows us essentially to be able to make compound angles. So typically you've got just a single line that comes out, and within that you have no adjustability. So for us to be able to just use a single hard line to connect to all the different possibilities of fuel injectors, because these fittings are, some come in the side, some come down from the top, some go straight in at 90 degrees. LB7 Duramax is almost vertical. There's so many variations in these angles that we would have to make probably 5 or 6 different lines to be able to, have one location where your high pressure connection is, and allow you to access or adapt to multiple angles. You'd have to have different lines for that to be possible. So we came up with this a couple of years ago, and I think this was only a prototype, and it worked good, but we actually need something that's just a little bit tighter radius than this, from leg to leg. So and this piece also utilized 3 pieces. So we had this main body here, which formed this right angle, and we had this fitting that screws in here, and this fitting that screws in here. And the whole premise behind that was if this got damaged, you would be able to replace it. But with the one that we're making now, we're actually making it the same material this was. I think it's a piece of 1 3/8 shaft material. You can see it still has a keyway in it here. And then once we machine it, we machine that area flat to give it a lower profile. And then we're going to come back, and as opposed to this one where the fitting is located near the end of the piece, we're going to center it here with this fitting, which will give us a much tighter angle, whereas this being 3 pieces, I think we're going to gain about an extra, probably total of about 1 inch of clearance when you figure the distance from here to the center line of this versus from here to the center line of that. So it's going to give us greater adjustability, in the angle of adjustability we have. We'll be able to keep things tighter and closer without, it changing due to the length, the distance from, and 1 inch probably doesn't seem like much, but when you're dealing in like an 8-inch area, 1 inch of adjustability is quite a bit. So what we'll be doing today is we'll be machining for this fitting, even though the one we're using is a little bit bigger in diameter. This is M14 thread, 14 millimeter by a 1.5 millimeter thread pitch. We'll be using a 16 millimeter by 1.5 millimeter thread pitch, and we'll use an end mill to machine the hole and the flat of the hole, because for this high pressure common rail, this thing will be subjected to roughly 33,000 P.S.I. The machine this will be going on is capable of 2200 bar or 220 MPa, which is roughly 33,000 P.S.I. So when we do that, we utilize a flat seat. So this will fit on another flat that'll be machined perfectly flat, and then this will bite into the surface to form our seal. I guess you would call it a face seal, but it doesn't use an O-ring or anything. It's just machined flat against machined flat, and they work. So compatibility, material compatibility, this is roughly about the same hardness as the material that we're using, perhaps maybe just a tiny bit harder. So this will actually embed into this material. We'll kind of cut down into it a little bit, and the seal will be formed by that tension placed upon the tension when we tighten this fitting. Just like you tension a bolt by tightening it, which stretches it. So this will be the opposite of the stretching, be actually compressing it. So without further ado, we'll get on to the machining process. All right, so I suppose there's several different possibilities in the way that you would skin a cat. But we're going to find the center of this piece here. And typically what I do, I'll just use a caliper and measure. Well, let's see if I can get in here. Just kind of get the flute lined up. Alright, we got 451. And on this side, we got, it's like 350. We're off about 100 thousandths. So we'll move it about 50 thousandths this way. 423. 379. Let's see what we got now. 400 thousandths almost exactly. And let's see what we got over here. Yeah, 401. 4.4 and a half thousandths. Okay, I'm going to say it's close enough. This is not critical. And looks like we were off half thousandths on our caliper to begin with. So once we've established our center, we can get our machine up here and connect to it. Okay, we're going to go ahead and zero everything. And let's add a little light here. Bring our tool up. And we're probably just going to eyeball the center of this. I've got the caliper handy. Let's measure it. So we'll come off of this one side over to here. 9/16. And then over to here, 103. So we're going to go that way just a tad. 970. 102. And I could look at the DRO and probably get this a whole lot quicker. Doesn't seem to be moving there. 972, 998, 993, 988. That's close enough. Okay, so what we're going to do is I'm just going to eyeball it, and I'm going to jog down. That's about close enough. And we're going to zero all. Okay, we've got a, we're going to be tapping this to 16 millimeter by 1.5 thread pitch. So this is roughly, it's 9/16 of an inch, 0.562 I suppose. 14 millimeter roughly diameter. Let's see exactly what it is. Yeah, 14.3 millimeters. Put our caliper away. And we're going to come down 450 thousandths. very slowly. A little more RPM. Two hundred thousandths. Three hundred thousandths. 400 thousandths. 451. Okay, we've made our hole. So what we did to line this up on the end, we just used a parallel. There we go. There's our machined hole. So now golly, that got warm. We'll chamfer it, and then we'll thread it. Alright, we're over here at our variable speed drill press. And I'm going to do a little cheat here. We're going to chamfer this hole. But what I'm going to do is I've got an Allen bolt here that's almost exactly the same diameter as our hole. A little too tight. So we're going to use that as a guide to line this thing up. Probably would have been a good idea to tighten it in the vise first, make sure we're still right. Yep, close enough. Okay, then we're going to put our chamfer in, chamfering tool, and hopefully it doesn't skate around. Oh yeah, worked excellent. Lined us right up. A little bit more. When we start our tap, we don't want it trying to find the center. Alright, that should be sufficient. Alright, now we're going to put our tap in. And we've got this drill press is really a neat machine. It has a variable frequency drive, so it's, we'll show you here, it's instant reversing, and it's pretty much infinitely variable speed. It also has a V-bout drive, which is variable, and then we can vary the speed with the variable frequency drive as well. So we can instantly reverse it for threading operations. So we can also do this in our VMC, do threading, but I'll be honest, this thing here does threading, quite a bit faster than the VMC even can. So we use rapid tap, RAPIDTAP. Really good lubricant for threading holes. Now we're not going to thread this hole completely. This type of tap that we're using is a straight flute, so it's going to push the chips down inside, and if we're not careful as we force this tap in, it's going to be working on top of those chips, scarring up the face that we're wanting to protect down in the bottom. So essentially we're only going to start this tap You know, maybe get 2 threads, and then we'll pull it out and we'll finish the rest of it by hand. We'll just put it in a vise. So here we go. Let me slow it down. Yeah, it's actually threading pretty good. So we'll just leave it there, and then we'll loosen our chuck, and we'll pull it out. And we'll take it out, and we'll go finish it off by hand. Alright, so here we are with our part. And let me get something to... Well, that's not much of a rag. See through that one. Let's use this piece of paper where we don't skin it all up. We'll chuck this fella in the vise. And, let me turn the air on. So you can see here, if we were to try to finish tapping this thing, see how much junk's in there. It's going to damage the seat that we're worked so hard to try to get in there. So we'll blow it out, get all the junk out of it, and then ultimately I need to get some fluted taps, spiral flute taps, so it will push the material up out of the hole. We've got some for some different sizes, but this is one size I don't have. Well, this stuff threads good. So we don't want to go too far. Generally just a couple of threads. And we'll pull it out, blow it out. And just a tad more and we'll be there. Half a turn or so. And even though this is a bottoming tap, it's not going to go all the way to the bottom. With our fitting that goes in there, I'm going to try to just touch the bottom with it, but not force it once it gets down there. I think that's it. So our fitting, there we go. The threads don't start at the very bottom of our fitting. You know, I hate a leaking air fitting. Let me grab the fitting. Where'd I put it? Right, so here's our fitting. You can see the threads. I'm not sure, 1/8 of an inch or so before they start. Right, and here is the finished inside of our fitting. Wipe it out really good here. And I'll show you also what we're up against. Okay, you see this one's going to have to go straight in. This one is almost vertical. This one goes in from the side. This one goes in way down on the bottom. This one goes in at an angle. There's a myriad of different angles that you have to be able to overcome. Oh yeah, fits good. And then now we've got to drill our passage hole. And we just do that with a hand drill and just a regular drill bit. Let's see which one of these drills. That one. I think that may be a 093 hole. Yeah, actually it is. I was going to go 1/8, but it doesn't necessarily have to be that big. So we'll drill it with this. What size is that? 7/64? Not sure what the decimal equivalent would be. Barely. Does this thing need to be sharpened? I believe so. Let me sharpen it right quick. Leaky things. Alright. Yeah, sharpening drill bits is a required skill, I suppose. I don't have enough length there. Choke up on it a little bit. I think I stuck it. Alright, let's see if we have an intersecting hole now. See if we blow anything up out of here. Yay! Alright, let's see. I need to drill back through that, and I think there's a burr or two. You know, this common rail stuff, this is going to be going into a fuel injector, so you know, we've got to really get this stuff clean. Deburr it, ultrasonic. It runs some yeah, I think we got it. Now this intersecting hole is 1/8 of an inch. So we'll run an 1/8 of an inch and 1/8 inch drill bit back through here. Okay, seems to be cleared out there. Alright, and there essentially, let me blow it out again. Oh, I gotta get a nut. Do I have one here? You know, this is the wrong size, but you'll understand. No, you won't either. You won't understand the principle of that. Let me grab the nut. So these are the what you would call a fuel line nut. Injector. This fits the injector. It's M14 by 1.5. We also have these M12 by 1.5 as well. And we've got a left-hand thread here, and internally we've got a right-hand thread. So what we'll do is we'll start it on here, as you can see, and then we'll take an appropriate injector, and as we tighten it, see, acts essentially like a tie rod end that you adjust, and it'll tighten up against it. So it's pulling this as it's pulling it into the threads this way. It's pulling this piece, the cone, this way. So you never have the line end, and we would say this machine end that we have here, we would call this our line end, or our cone, which is 60 degrees. It doesn't turn against this seat. So anyway, this This works really well. It's a very clean and neat way to make your connection. And as you can see, now we can establish any angle. All right, this from a fixed position. Okay, this angle. Okay, this angle. Okay, this angle. This angle. You can see we can go in any angle that we need to go, essentially, with this. And we'll show you video later of this thing actually on the machine. But this is how we make these fittings. Pretty neat little deal. So we thank you for watching. If you got any questions, put them in the comments below. And we stay pretty busy, so we'll do our best to answer some of your comments. And we're by no means the greatest out there. This is a necessity, and this is the fulfillment of the need of that necessity in making these things. We're not claiming to be the world's greatest machinists or even a great machinist. Most of the stuff we learned is, I call it blacksmith machining. It's just, we pound our way into it until we get something that works. So some of these other guys you watch, they're going to get things within a tenth of a thousandth of an inch. And some of the machining we do requires that kind of a precision tolerance, like the common rail pump shafts that we make. We get those things to within a couple of tenths of thousandths on diameters. So, and that's critical, and also the heat treatment and other things, other facets of that. But not all machining requires such great tolerance. So this is just, we could be within 50 thousandths, anyway on one of these, and it wouldn't be critical, wouldn't make any difference. But we want to make it look symmetrical and uniform. So, we're going to try to get it within, 5 or 10 thousandths anyway. And anybody can do that. It just takes a moment longer to do it. But thank you for watching.